Question 2.1 says a geometric sequence has term 3 equal to 20 and term 4 equal to 40. And the first thing they want you to calculate is the common ratio. Now, you guys remember that the common ratio is represented by R. And ratio means fraction. So the formula that we usually use would be term 2 over term 1 or term 3 over term 2. And what you guys notice from that is that we can use any two consecutive terms from the geometric sequence to calculate R. And the good thing is that we are given two consecutive terms. We've got term 3 and term 4. So to calculate this, we're going to say R is equal to term 4 over term 3. Substituting the values, that is going to be 40 over 20. And you end up with R being 2. So that is the common ratio. In 2.1.2, they now ask you for a formula for Tn. And since this is geometric, you guys need to remember that Tn is equal to AR to the power n minus 1. That is the formula that we're working with. Now, there's missing information here. In order to get the formula, not only do you need R, but you also need A. So the problem here is that we don't actually have A, but we can calculate it. Since we know what term 3 and term 4 is, as well as the common ratio, we can use that to get A, which, remember, A is term 1. So A is term 1. So if we were to look at the terms that we have, we've got term 3 and term 4, and we need to get A. Now, there's actually two ways that you can get A. Remember, A is your first term, and filling in what term 3 and term 4 is, we can actually work backwards to get term 1. So remember, when you're going forward with geometric, we are multiplying by 2. That is what the common ratio is. But when we work backwards, we are going to divide by 2. So if we take 40 divided by 2, we get 20. 20 divided by 2, that gives you 10. 10 divided by 2 would give you 5. And since A is term 1 is equal to A, that means that A is equal to 5. So you would definitely be allocated a mark for getting the A value first. Now that we know what A and R is, we can write down the general term in the format Tn is equal to AR to the power n minus 1. A is 5. R is 2 to the power n minus 1. So you can have R in a bracket even if you don't. So if you write it without the bracket, 5 times 2 to the power n minus 1. So all depending on how you write it, either you have the bracket around your R value, or if you don't have the bracket, make sure you have this dot, which is quite well pronounced, to show that these are two separate values that are multiplied together. Okay, so that is the general term. Now we're going to move on to question 2.2. It says the following sequence has the property that the sequence of the numerators is arithmetic. So I'm just going to pause there and make sense of this information. The sequence of the numerators is arithmetic. That means that in these fractions that we are given, these numerators are all arithmetic. And if we just analyze them, we've got 2, -1, -4. That makes sense because remember, arithmetic sequences have a common difference, constant difference. And we can see that from 2, if we subtract 3, we get -1. We take -1, subtract 3, we get -4. So it is arithmetic, and we've also just established that the difference is -3. We are subtracting -3 from each term. Okay, let's continue reading the question. And the sequence of denominators is geometric. Extremely important information. So all of these denominators, 1, 5, 25, they are all geometric. And we know that geometric has a common ratio. So if we look at this, we've got term 1 as 5, term 1 as 1, term 2 as 5, and term 3 as 25. If we use these terms to get the common ratio, R is 5. So that is what we are multiplying each term by. Okay, the first question says, write down the fourth term of the sequence. If we continue in this manner, in the numerators, we would expect the fourth numerator to be -7. And how we get that is we take the -4, we minus the 3, which is the difference, and we get -7. And we expect the denominator, the fourth denominator, to be 125. Because remember, we are multiplying by 5 each time. So let's write that down. Okay, so here we have it. Term 4 would be -7 over 125. Now for 2.2.2, we are required to determine a formula for the nth term. So nth term meaning general term. However, we've got two different number patterns in one, where the numerator is arithmetic and the denominator is geometric. So here's what I'm going to do. I'm going to get the nth term for each pattern separately, and once we are done, we are then going to write it in the fraction format. Okay, so let's first work with the arithmetic part. And remember, once we get it, that is going to go in the numerator. So arithmetic general term is Tn is equal to A plus D into n minus 1. So A is the first term, which is 2. The difference is -3 into n minus 1. Let's take that -3 and multiply into the bracket. It's going to give us -3n plus 3. Gathering like terms, we have 5 minus 3n. Now, focusing on the geometric, and remember that goes in the denominator. That is in the format Tn is equal to AR to the power n minus 1. Now I just want to go back up to check what the first term was. Okay, it was 1. So A is 1, R is 5. So since A is 1, it's not really necessary to show it because we're going to have 1 times something. So I'm going to leave that part out. And then R is 5 to the power n minus 1. Now we can write out the final general term where the numerator is the arithmetic part, 5 minus 3n, and the denominator is the geometric part. So this would be your final answer. Now for question 2.2.3, this is quite simple because they say determine the 500th term of the sequence. And why this is simple is because you have just calculated your general term. So to calculate T500 just requires us to substitute 500 in place of n. So that is going to be term 500. Numerator is going to be 5 minus 3 times 500. Denominator is going to be 5 to the power 500 minus 1. So solving the numerator gives you -1495. And in your denominator, that is going to end up being 5 to the power 499. Now you guys will notice that if you put that on your calculator, you get an error. That error does not mean that it's undefined. It just means that the value is too large for your calculator to compute. So we're just going to write that as 5 to the power 499. So that would be it. Now we've got one last question. It says, which will be the first term of the sequence to have a numerator less than negative 59? So notice that numerator is in capital letters because we are focusing only on the numerator. And they say that the numerator must be less than 59. So we've got that general term for the numerator, and we're going to write this out mathematically, where we set that general term less than negative 59, and from there we're going to solve for n. Since we need to know which term, or which will be the first term in the sequence when that numerator is less than negative 59. So remember that the general term for your numerator was 5 minus 3n. So we're going to have 5 minus 3n less than negative 59. And our aim from here is to solve for n. So the first thing we're going to do is take this 5 over to the right. When it goes over, it is going to become a negative 5. So we have negative 59 minus 5, which is negative 64. Now to get n alone, we are going to divide throughout by its coefficient, which is negative 3. So on the left hand side, we have n. And then, very, very important, this is something you actually learned in primary school regarding inequalities. Whenever we divide by a negative value, the sign changes. So this is going to go from being a less than to being a greater than. And on the right hand side, negative 64 over negative 3 as a fraction would be 64 over 3, but I am concerned with the decimal, which is 21.3 recurring. So it's 21.333, and it continues like that. I will just take 2 decimal places. Now remember that this is an inequality. To understand what this is saying, n is greater, or n must be greater than 21.33. So we know that n cannot be decimal values. N has to be a whole number. So the next whole number that is bigger than 21.33 is going to be 22. So n must be 22. So that would be your answer. There's nothing else for you to write, but let's understand what this means in terms of the question. If we just go back up to that question, we needed to know what the first term of the sequence will be to have a numerator less than negative 59. So what this tells us is that for term 22, it will have a numerator that is less than negative 59. So that 22 was what we needed to calculate. We needed to know which term exactly will have a numerator less than negative 59. So we are done.